Have you ever looked up at the night sky, a vast, dark canvas sprinkled with countless stars, and felt a sense of wonder? Each star is a data point, a source of information about the universe's history, its composition, and its future. In much the same way, we now live in a digital universe, a cosmos of data created every second of every day. Data science is our telescope for this new reality. It is the grand discipline of exploring this digital cosmos, of finding patterns, connections, and meaning within the endless sea of information. Think of it as modern-day astronomy, but instead of charting stars, we are charting human behavior, preferences, and interactions through the data we leave behind. Machine learning is a brilliant star within this data science constellation. It is not just a tool, it is a revolutionary approach, a fundamental shift in how we seek knowledge. Where traditional programming requires us to write explicit, step-by-step instructions for a computer to follow, machine learning flips the script entirely. We don't tell the machine exactly what to do. Instead, we show it. We provide it with vast datasets, cosmic clouds of examples, and we task it with discovering the underlying rules and patterns on its own. It's the difference between giving someone a fish and teaching them how to build a fishing fleet that can survey the entire ocean. This process is a journey of discovery, much like the scientific method itself. We start with a question, a cosmic mystery we want to solve. We gather our data, our observational evidence from the digital world. Then, we unleash our machine learning models, our intelligent probes, to navigate this data and report back with insights. These models are not just crunching numbers, they are building a conceptual framework, a theory of the data. They are learning to see the invisible threads that connect seemingly random events, much like how we discovered the law of gravity connecting a falling apple to the orbiting moon. The beauty of this field lies in its boundless curiosity and its power to reveal the unseen. It's a quest to understand the universe of our own creation, the digital one. Data science provides the framework for this exploration, setting the stage and defining the questions we dare to ask. Machine learning, then, is the engine of discovery, the intellectual thrust that propels us toward answers we couldn't have imagined. It's a partnership between human ingenuity and computational power, a collaboration that allows us to perceive our world, both physical and digital, with a clarity and depth that was once the stuff of science fiction. You might think this grand exploration of data is confined to laboratories and supercomputers, but you'd be mistaken. The echoes of data science are all around you, subtly shaping your daily experience in ways you might not even notice. Consider your favorite online store. When it suggests a new book or a gadget that you find surprisingly perfect, that isn't magic. It's data science in action. The system has analyzed your past purchases, the items you've browsed, and compared them to the behavior of millions of other shoppers, finding cosmic patterns in the data to predict what you might like next. It's a digital recommendation engine powered by machine learning. Or think about the voice assistant on your phone or in your home. When you ask, "What's the weather like today?" a complex ballet of processes unfolds. Your spoken words are captured, digitized, and sent into a vast model trained on countless hours of human speech. The machine has learned to recognize the patterns of your language, to distinguish your phonemes, and to understand the intent behind your query. It doesn't know what weather is, but it has learned to associate your specific sound waves with a request for a meteorological report, pulling the relevant data and speaking it back to you in a synthesized voice. It's a daily miracle of applied data science. This extends to the very music you listen to and the shows you binge watch. Streaming services are masters of this craft. They are not just libraries of content, they are sophisticated ecosystems of taste-making. By analyzing what you watch, when you watch it, what you skip, and what you rewatch, their machine learning algorithms build a detailed profile of your preferences. This profile is then used to curate playlists and recommend series, creating a personalized media universe designed to keep you engaged. It's as if you have a personal astronomer charting your entertainment galaxy, always pointing you toward the next bright star you're destined to enjoy. Even your daily commute is becoming a data science experiment. Navigation apps don't just have a static map of the roads. They are constantly ingesting a river of real-time data, traffic speeds from other users' phones, reports of accidents, and information about road closures. Machine learning models process this torrent of information to predict traffic flow and calculate the fastest route for you at that very moment. You are not just following a map, you are following a prediction, a path charted through the complex, ever-changing cosmos of urban traffic, all thanks to the quiet, powerful work of data science happening behind the screen. So how do we teach a machine, a collection of silicon and circuits, to perform these seemingly intelligent tasks? The process is less like giving orders and more like raising a very, very fast learning apprentice. Imagine you want to teach a computer to recognize a cat. In the old way of programming, you'd have to write an impossibly complex set of rules. A cat has pointy ears, whiskers, forelegs, a tail. But this approach is brittle and fails constantly. What about a cat with folded ears? Or one whose tail is hidden? The universe of cat appearances is too vast for simple rules. This is where the magic of machine learning comes in. Instead of giving it rules, we give it experience. We become the sorcerer, and the algorithm is our apprentice. We show it a massive dataset, let's say 1 million pictures of cats. For each image, we provide a label. This is a cat. The apprentice doesn't know what a cat is, but it starts looking for patterns. It adjusts its internal parameters, its own nascent understanding, trying to find the common visual signals present in all the images labeled cat. It's a process of trial and error on a cosmic scale, happening millions of times per second. Through this training, the model builds its own internal representation of catness. It's not a list of rules we wrote, but a complex, multi-dimensional mathematical concept that it discovered on its own. It learns to associate certain textures of fur, specific shapes of eyes, and the unique geometry of a feline face with the label cat. When we then show it a brand new picture of a cat it has never seen before, it can consult this learned representation and make a highly accurate prediction. Based on everything I've seen, this fits the pattern of a cat. It has generalized from the examples to a broader understanding. This is the core principle behind most machine learning. Whether it's recognizing cats, understanding speech, or recommending movies, the method is the same. Provide vast amounts of labeled data and let the algorithm learn the patterns for itself. It's a powerful partnership. We provide the raw materials of knowledge, the data, and the machine, our tireless apprentice, does the heavy lifting of sifting through it all to find the hidden wisdom. It's a new kind of science, where our hypotheses are tested not by us, but by the learning machines we create. The ability to teach computers to recognize patterns is not just for recommending products or identifying pets. This fundamental capability is igniting revolutions across nearly every field of human endeavor, expanding the universe of what is possible. Take the field of natural language processing, or NLP. This is where we teach machines to understand the most human of all data, our language. From translating between languages in real time to analyzing the sentiment of millions of social media posts, NLP is breaking down communication barriers and giving us a new lens to understand our collective consciousness. It's like having a universal translator and a global pollster rolled into one. Then there is the awe-inspiring domain of computer vision, or CV. Beyond just recognizing cats, CV is giving machines the sense of sight. This technology is at the heart of self-driving cars, which must interpret a constant stream of visual data to navigate the world safely. In medicine, computer vision models are being trained to scan medical images, X-rays, MRIs, and tissue slides to detect signs of disease, sometimes with a speed and accuracy that rivals human experts. It's as if we've built a microscope that can not only see, but also understand what it's looking at, searching for cosmic anomalies in our own biology. The impact of machine learning is rippling through every science, from astronomy to genetics. Astronomers now use machine learning to sift through telescope data, discovering new planets orbiting distant stars and classifying galaxies far faster than any human could. In genetics, algorithms are helping us understand the incredibly complex code of DNA, predicting how certain genetic mutations might lead to disease and paving the way for personalized medicine. the machine is becoming an indispensable partner in our quest to decode the universe, from the largest galactic structures to the smallest building blocks of life itself. For you, the tech students of today, this is the world you are inheriting. Understanding these principles is no longer a niche specialty. It is becoming a fundamental literacy for the 21st century. Learning about machine learning is like learning the laws of physics in a new age of discovery. It gives you the power not just to use the technology of the future, but to create it. You are standing at the shore of a new cosmic ocean of data, and with the tools of data science and machine learning, you have the ability to build the ships that will explore it. The journey is just beginning.